Solutions are homogeneous mixture of two or more substances in same or different physical phase. What are gaseous solutions? Gaseous solutions are the solution in which solvent is gas, solute is solid or liquid or gas. Now I am finding the mole fraction of component A, mole fraction of component B. Therefore, you take number of moles of that component. Hello, my dear students. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear student, today I am going to explain or discuss about the chapter 1, that is, the chapter name is Solutions. What's the name of chapter? Solutions. In that, today I am going to do first session. Solution, it's a physical chemistry chapter. Today in this class, I am going to give definition for solution. And you know that already solution has two components. One is solute and solvent. Next, types of solutions. So here I have to study about concentration of solutions. In concentration of solutions, the concentration is expressed by using different units. The first unit is mass percentage, second unit is volume percentage, third one is mass by volume percentage, fifth one is parts per millions, last one is mole fraction. So, in this session, I am going to give definition about solutions as well as classification of solutions. And the two important components of solution is solute and solvent. And I'll give definition for concentration, and concentration is expressed by using different units. In this class, I am going to explain about the 5 units of concentration. The 5 units of concentration are, first one mass percentage, next one is volume percentage, next one is mass by volume percentage, next parts per million, it is also called as ppm, next to mole fraction, Now, consider solutions. Chapter name is solutions. But you want to know about what exactly the definition for solution. Nan student adak tilkondiddenu andre solution andre when any solid is dissolved only in liquid. ನನ್ನ ತಲೆಯಲ್ಲಿ ಏನಿತ್ತು ಅಂತಂದ್ರೆ ನಾನು ಸ್ಟೂಡೆಂಟ್ ಆದಾಗ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಸಾಲಿಡ್ ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆದ್ರೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸೊಲ್ಯೂಷನ್. ದೇರ್ಫೋರ್ solute is always solid, solvent is always liquid. ಅದರಲ್ಲೂ ಸಾಲ್ವೆಂಟ್ ಆದರೆ ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ವಾಟರ್ ಅಂತಾನೆ ಅನ್ಕೊಂಡಿದ್ದೆ. ದಟ್ಸ್ ವೈ ಯಾವಾಗಲೂ ನಮಗೆ ಸೊಲ್ಯೂಷನ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಡಿ ಅಂದಾಗ ಯೂಸ್ ಟು ಗಿವ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್, ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಶುಗರ್ ಸೊಲ್ಯೂಷನ್. ನನಗೆ ಎರಡೇ ಸೊಲ್ಯೂಷನ್ಸ್ ಗೊತ್ತಿದ್ದು, ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಯಾವುದು, ಶುಗರ್ ಸೊಲ್ಯೂಷನ್. ಮತ್ತೆ my mind was fixed to that definition that any solid is dissolved in liquid, that is called as ಏನಂತ ಹೇಳ್ತಾ ಇದೆ, solution. But my dear student, it's a wrong definition for solution. Don't think that only solid must dissolve in liquid to get solution. What exactly is solution? In the first PUC, in the first chapter of physical chemistry, that is under some basic concepts of chemistry, you learnt about mixtures. In mixtures, there are two types of mixtures. Homogeneous mixtures as well as what? Heterogeneous mixture. Homogeneous mixtures means when you add components A and B, will you observe only one phase or one layer. But heterogeneous mixtures, when you add two components A and B, A forms one layer, one phase, A forms one phase and B forms another phase. One you can find out the components which are present in the mixture. Here we not possible to identify which is A and which is B. Now this mixture, when you are going to observe only one phase, that is called as what? Homogeneous mixture. You are going to observe two or more phases or two or more layers, it is called as what? Heterogeneous mixture. Why I am explaining about homogeneous mixture as well as heterogeneous mixture, my children? Solution is homogeneous mixture. Solutions are homogeneous mixture of two or more substances in same or different physical phases. When two or more substances mixed with each other with same or different physical phases, same if the physical state is same or physical states of that phases are different, components are different, then that mixture is called as what? Solution. Therefore, solution is a beautiful example for homogeneous mixture. I'll repeat once again. What's the definition for solution? Solution is a homogeneous mixture of, solutions are homogeneous mixture of two or more substances. Now, air also example for solution. Alloy also example for solution. Sea water also example for solution. See, air. Why air is example for solution? Because as you know, air contains so many gases. But we are not distinguishing between this is oxygen layer, this is nitrogen layer, and this is carbon dioxide layer. So all gases are homogeneously mixed with each other. It is called as what? Air. So air is a beautiful example for homogeneous mixture. Therefore, solution means not only salt solution as well as sugar solution. Example for solution is air, alloy, seawater. Air, alloy. Examples are air, alloy, seawater. Air, alloy, seawater. These are beautiful example for solution. Therefore, solution is an example for what? Homogeneous mixture. Homogeneous mixture. Once again, I'll repeat. What is solution or what are solutions? Solutions are homogeneous mixture of two or more substances in same or different physical phase. The substances forming the solution are called component of the solution. The substances which form solution, they are called as what? Components of the solution. If you consider any solution, if it has only two components, how many components? Two components, then that solution is called as what? Binary solution. Then that solutions are called as what? Binary solution. Alige, what are binary solutions? A solution that contain two components are called binary solution. Solutions which containing two components are called binary solution. What are the two components of the solution? One is solvent, another one is solute. One is solvent, another one is solute. So, what are the two components of solution? The two components of solution are, first one is solvent, second one is solute. What is binary solution? Binary solution is a solution which containing only two components. What are the two components of solution? The two components of solution are, one is solvent, another one is solute. For example, you are preparing tea or coffee, otherwise you are preparing Horlicks, or you are preparing sugar solution, salt solution. What you are going to do, you will take a cup of water. To that you are going to add 1 spoon or 1 spatula of what? Sugar. So, when I am going to take water in this beaker, you are going to add 1 spoon of sugar. 1 spoon of what? Sugar. 1 spoon of sugar. Where the quantity of this water is more. Therefore, the component is present in large excess which is inside the beaker. 1 spoon of sugar, it is present in small amount. Anything which is present in largest portion, it is called as solvent. When it is any component which is present in smaller portion, it is called as what? Solute. Therefore, what are the two components of the solution? The two components of solution are solute and solvent. What is solvent? The component of the solution which is present in larger proportion is called as what? Solvent. Which is present in smaller proportion, it is called as what? Solute. Therefore, one I can tell solute plus solvent is equal to solution. Solute plus solvent is equal to solution. Therefore, what are the two components of solution? The two components of solution are solute and solvent. The part which is present in larger quantity or larger proportion is called as solvent. The part which is present in small amount, it is called as what? Solute. Therefore, my dear students, solute plus solvent is equal to what? Solution. Therefore, fix in your brain. So, there are binary solution. Binary solution containing how many components? Two components. One is solute, another one is what? Solvent. Now, types of solution. Based on the physical state of solvent, there are three types of solutions: solid solution, liquid solution, gaseous solution. What are the three types of solutions? Based on the physical state of the solvent. Based on the physical state of the solvent, what are the three types? First type is solid solution, second type is liquid solution, third type is gaseous solution. Please observe the flow chart. So what I about to now I'm going to explain about what? Types of solution. What are the types of solution? On which basis it is classified? On the basis of physical state of solvent, the solutions are classified into three types: solid solution, liquid solution, as well as what? Gaseous solution. Now I am going to discuss one by one. What is solid solution? For that example, what is liquid solution? For that example, what is gaseous solution? For that example. The first type of solution, that is solid solution. Solid solution means here solvent is always solid. But solute is either solid, liquid, gas. Okay, solvent is always solid. That means the component which is present in larger proportion, is called as solvent. In this type of solution, solid is present in larger proportion. Solute may be solid, liquid, gas. Hagare, what's the definition for solid solution? Solid solution in which the solvent is solid and the solute is either solid, liquid or gas. Yenagirutte? Solvent ಏನಾಗಿರುತ್ತೆ? Solid ಆಗಿರುತ್ತೆ. Solute is solid, liquid or gas are called solid solution. So, three possibilities are: solute is solid. Okay, that means solvent is solid. Now it is solvent. Solvent is solid. Next, now I'll consider solute. Solid, liquid, gas. Solute is solid. Solute is liquid, solute is gas. That is solid in solid. So, solid in solid. This is second one. Liquid in solid. Third one, gas in solid. Here solid is solvent. Solutes are solid, liquid, gas. Okay, what is solid solution? Solid solution is a solution in which solid is solvent. Solute may be solid, liquid, gas. The first one, solute is solid. Copper is dissolved in gold. Here copper is also solid, gold also solid. Next, solute is liquid. Amalgam of mercury with sodium. Amalgam of mercury is liquid, sodium is solid. Solution of hydrogen in palladium. So, this is gas. Palladium is solid. Observe, solvent here gold, here solvent is sodium and here solvent is palladium. All are solids. But here copper is solid, copper is solid, amalgam of mercury is liquid, as well as solution of hydrogen is in a gas. Okay, so therefore what are the example for solid solute which is dissolved in solid solvent? The example for solid solute which is dissolved in solid solvent is copper dissolved in gold. Give an example for liquid solute dissolved in solid solvent, that is amalgam of mercury. What is amalgam andre? Amalgam is alloy which containing one of the metal what? Mercury with sodium, that is what? Liquid form. So give an example for solute gas is dissolved in solvent gas. Example, solution of hydrogen in palladium, Therefore once again solid solutions are further divided into three types. So what is the classification of solid solution? Solid in solid, liquid in solid, gas in solid. Once again I'll repeat, solid in solid, liquid in solid, gas in solid. Solid in solid, copper dissolved in gold. Liquid in solid, amalgam of mercury which is dissolved in sodium, Last one, gas in solid, that is solution of hydrogen on palladium, Next, liquid solution. My dear student, please guess what's the definition for liquid solution? So liquid solution means your solvent is liquid, solute is solid, liquid, gas. The solution in which the solvent is liquid, solute is either a solid, liquid or gas. What are the three possibilities? First possibility, solid in liquid. Second possibility, liquid in liquid. Third possibility, gas in liquid. Observe my student, always the solvent is gas. I am changing only the solute. Alige first one solid in solute, solid in liquid. Glucose is dissolved in water. Glucose is solid, water is liquid. So solute is liquid. Ethanol is dissolved in water. This is liquid and this is also liquid. Solute is gas. Oxygen dissolved in water. Oxygen is gas. Water is liquid. Observe here, all the three are what? Liquids. Here I dissolved solid, here I dissolved liquid, here I dissolved gas. Therefore, give an example for solid solute dissolved in liquid solvent, solid solute dissolved in liquid solvent, glucose dissolved in water. Give an example for liquid solute dissolved in liquid solvent, ethanol is dissolved in water. Give an example for gas solute dissolved in liquid solvent, that is gas dissolved in water. See here, it's shown in by the diagrams that how solutes are added to solution. Third type of solution is gaseous solution. What is gaseous solution? In gaseous solution, solvent is gas. Solute may be solid, liquid, gas. What are gaseous solution? Gaseous solutions are the solution in which solvent is gas, solute is either solid, liquid or gas, are called gaseous solution. So once again I'll repeat, my dear student, what are gaseous solutions? Gaseous solutions are the solution in which solvent is gas, solute is solid or liquid or gas. Based on that, there are three possibilities. What are the three possibilities? When solute is solid, when solute is liquid, when solute is gas. Solute is solid, solute is liquid, solute is gas. But here solute is solid, solute is liquid, solute is gas. But solvent is always gas. Observe here. Here solvent is nitrogen gas. Here also solvent is nitrogen gas. Here also solvent is nitrogen gas. But solute is solid, which is your camphor. Therefore, solid solute in gaseous solvent is camphor in nitrogen gas. Second one, solute is liquid. Chloroform mixed with nitrogen gas. Chloroform is mixed with nitrogen gas. Here, solute is liquid, solvent is gas. Third one, solute is gas as well as solvent also gas. Mixture of oxygen and nitrogen. Mixture of oxygen and nitrogen. Therefore, what are gaseous solution? Solution in which solvent is gas, solute is solid, liquid, gas. So, in that three type, solid solute in gas, liquid solute in gas, gas solute in gas. Solid solute in gas is camphor in nitrogen, liquid solute in gas solvent, that is chloroform is mixed with nitrogen. Last one, solute is gas, solvent is also gas, mixture of oxygen and what? Nitrogen gas. Once again, what I discussed, that is type of solution, I prepared a chart or column wise, so it is easy to remember. First type, gaseous solution, liquid solution, solid solution. Gaseous solution, solvent is always gas, solvent is always gas. Gas in gas, liquid in gas, solid in gas, both are gases. Solute and solvent both are gases, that is mixture of oxygen and nitrogen. Mixture of oxygen and nitrogen. Liquid in gas, chloroform and nitrogen. Chloroform and nitrogen. Chloroform and nitrogen. Solid in nitrogen, camphor in nitrogen. Camphor in nitrogen. Camphor in nitrogen. So, next liquid solution. Here all the three cases, liquid is solvent, liquid is solvent, but solute is gas in liquid, liquid in liquid, solid in liquid. Gas in liquid, oxygen dissolved in water, liquid in liquid, ethanol dissolved in water, solid dissolved in liquid is glucose dissolved in water, glucose dissolved in water. Next, last type, solid solution. Solid solution means solvent is always solid, therefore solvent here is solid, but solutes are gas in solid, liquid in solid, solid in solid. Gas in solid is solution of hydrogen in palladium, liquid amalgam of mercury with sodium, copper dissolved in gold. So, this is the how many types of solution? Totally 9 type of solution. 3 comes under gaseous solution, 3 comes under liquid solution and 3 comes under what? Solid solution. When you want to prepare, for example, how to prepare solution? Whether you had to add solute to solvent or solvent to solute. To prepare solution, you have to take solvent in a container, either in the conical flask or in the beaker in practical classes in the laboratory. But in your house also you have to prepare so many solutions. You are preparing tea, to that you have to add sugar and you have to prepare Horlicks, Boost, as well as you have to prepare juice. So, how can you prepare this? First you take solvent. Solvent. What is solvent? Which is present in larger quantity or large amount, or which is present in excess. It is called as what? Solvent. To that, you have to add solute. It is in a small quantity. Always, my dear student, solute should be added to solvent. Solute should be added to solvent. Sugar is added to milk. Not milk is added to sugar. Therefore, the first component always you have to take is solvent as a first component, solute as a second component. Therefore, in this chapter, if I use subscript A or 1, it stands for solvent. B or 2, it stands for solute. Therefore, for example, N1, W1, M1. Here, subscript or A. So, 1 or A represents solvent. N is number of moles of solvent. So, my dear students, how to prepare solution? What is solution? It's a mixture of solute and solvent. First, always you have to always take solvent. Therefore, it is a first component. or is a phase A, phase A. To that you are going to add solute, it is always 2 or it is phase B. Therefore, if I use notation N1, W1, M1 or A, NA, WA, MA means what stands for N? N is what? Number of moles of A means what? Solvent. W1, mass of solvent, mass of solvent. W1, M1, so molecular mass of solvent, molecular mass of solvent. If I take N2, W2, M2 instead of 2, if it is B, number of moles of solute, mass of solute, molecular mass of solute, ಅಲ್ಲಿಗೆ 1 or A stands for solvent, 2 or B stands for solute. Therefore, always to prepare solution, first component should be solvent. Second, for example, I'll tell you the one sentence. 20 gram of benzene is added to 100 ml of water. So, which one is added to which one? Benzene is added to water. Therefore, water considered as solvent, benzene is considered as what? Solute. Solute is always added to solvent, so it should not be reversed. Okay? Therefore, while preparing solution, which is the first component is solvent, second component is solute. Therefore, in this chapter, if I use notations 1 or A, it stands for solvent. 2 or B, it stands for what? Solute. Okay. Now, we are using terminology always in physical chemistry. Concentration. What is concentration? The amount of solute present in a given quantity of solvent. For example, if it is 100 ml, how much amount of solute is dissolved in 100 ml of water? Therefore, what is concentration of the solution? Concentration of the solution is defined as it is the amount of solute. Dissolved in a given quantity of solvent. Is the amount of solute present in given quantity of solvent. That is called as what? Concentration. What is concentration? Concentration is the amount of solute. Present in given quantity of solvent. Therefore, the various methods to express units concentration of solution. Various units. First one, mass percentage. Second one, volume percentage. Third one, mass by volume percentage. Fourth one, parts per million. Fifth one, mole fraction. Sixth one, molarity. Seventh one, molality. Eighth one, normality. What are the 8 units or 8 method of expression of concentration of solution? Sometime, for example, SI unit of mass andre kg antivi. Is it possible to express everything in kg? Oh no. Here, for example, I need mercury. It is not, I'm not going to buy that mercury in terms of kg, in terms of milligram. If I'm going to gold shop, if I want to buy gold, I'll give me 20 gram of neck chain or 10 gram of stud or 20 gram of bangle. It is expressed in what? Gram. If you go to bakery, you are going to take bread in terms of pound. You won't ask bakery person that I need 1 kg of bread. But SI unit of mass is kg. But in our daily life, according to our comfortable level, we are using units. Similarly, concentration can be expressed by using different units, but we are using some, depending upon the situation, we'll use that units. Okay, so what are the 8 units of concentration? The 8 units of concentration is first one what? Once again I'll repeat. First one, mass percentage. Mass percentage. W bar W. Volume percentage. V bar V. Mass by volume percentage. W by V. Next, parts per million. Parts per million. Fifth one, mole fraction. Fifth one, mole fraction. Sixth one, molarity. Sixth one, molarity. Seventh one, molality. Seventh one, molality. Eighth one, normality. Eighth one, normality. Okay. Let us consider mass percentage. Observe here, W bar means here solute and solvent. Mass means solute and solvents. Both are solute and solvents. Both are solids. When this unit is useful when both solute and solvent are solid. Solute and solvents both are solid. It is expressed by mass percentage. Mass percentage of a solution is defined as mass of the solute dissolved in 100 gram of the solution. It is percentage means you have to think that the solution quantity must be 100. It is 100 gram, not 100 ml. Therefore, what is mass percentage of a solution? Mass percentage of a solution is defined as it is a mass of the solute dissolved in 100 gram of the solution. Therefore, what's the formula for mass percentage? Mass of a component in the solution divided by total mass of the solution. Mass of that component in the solution divided by total mass of the solution into 100. So, when it is useful? When both solute and solvents are solids. So, application. Mass percentage is commonly used in industrial chemical application. It is used in, industrial chemical application. Industrial chemical. Commercial bleaching. You know that bleaching means, so you have to convert a colorful compounds into colorless compound. So, that is known as what? Bleaching. So, now it is used in mass percentage used in commonly in industrial chemical application. Industrial chemical application. Once again I'll repeat, what's the definition for mass percentage? Mass percentage is defined as the mass of the solute. Mass of the solute dissolved in 100 gram of the solution. 100 gram of the solution. Therefore, you can create formula for this equation, formula for this. What is mass percentage? Mass of a component in the solution, mass of the component in the solution divided by total mass of the solution into 100. Next, volume percentage. So, if you understand about what is mass percentage, volume means V bar V means for which type of solution you guess? It is useful when both solute and solvents are liquids. Mass percentage is used when both are solids. Volume percentage is used when both are liquids. Can you guess the definition for volume percentage? It is the volume of the solute, their mass of the solute. Here it is volume of the solute dissolved in 100 ml of the solution. 100 ml. Their mass ಆಗಿರೋದ್ರಿಂದ ಅಲ್ಲಿ 100 ಗ್ರಾಮ್ ಅಂತ ತಗೊಂಡೆ. ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಆಗಿರೋದ್ರಿಂದ 100 ml ಅಂತ ತಗೋತಾ ಇದೀವಿ. ಹಾಗಾದ್ರೆ ವಾಟ್ಸ್ ದ ಫಾರ್ಮುಲಾ ಫಾರ್ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್? ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಕಾಂಪೋನೆಂಟ್ ಇನ್ ದ ಸೊಲ್ಯೂಷನ್ divided by total volume of the solution. Previous mass percentage ಅಲ್ಲಿ ಏನು ತಗೊಂಡಿದೆ? ಎರಡನ್ನು ಮಾಸ್ ಅಲ್ಲಿ ತಗೊಂಡಿದೆ. ಏನಂತ? Mass of the component present in the solution divided by total mass of the solution. Now it is volume percentage. I am going to take in terms of volume. So, volume of component in the solution divided by total volume of the solution into 100. So, it is useful when both solute and solvents are liquid. 10% of ethanol dissolved in water. A 35% of solution of ethylene glycol and antifreeze used in cars for cooling the engine. 35% of ethylene glycol, 35% of ethylene glycol, it is used as antifreeze. It used as antifreeze used in cars for cooling the engine. Engines na cool ಮಾಡೋದಕ್ಕೆ ಕಾರ್ಸ್ ಅಲ್ಲಿ ಏನನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಇಥಿಲೀನ್ ಗ್ಲೈಕಾಲ್. ಇಥಿಲೀನ್ ಗ್ಲೈಕಾಲ್. ವಾಟ್ಸ್ ದ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ ಇಥಿಲೀನ್ ಗ್ಲೈಕಾಲ್? ದ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ ಇಥಿಲೀನ್ ಗ್ಲೈಕಾಲ್ is 35%. How much percent? 35%. It is used to cool engines in the cars. Next, mass by volume. Guess. One must be in mass, another in next should be expressed in volume. Therefore, the first stands for solute, second stands for, so here solute is added to what? Solvent. Mass by volume percentage of a solution is defined as mass of the solute dissolved in 100 ml of the solution. So, one should be taken in terms of mass, another should be taken in the terms of volume. Solute is in terms of mass, solvent should in terms of what? Volume. So, 100 ml of the solution. Therefore, what's the formula for mass by volume percentage? Mass of the solute divided by volume of the solution into 100. Mass of the solute divided by volume of the solution into 100. This unit is useful when one solute is solid and solution is liquid. Solute is solid, solvent is liquid, this unit is used. This unit is commonly used in medicines and pharmacy. The concentration of medicines, tonics, syrups, it can be expressed by using the concentration unit mass by volume percentage. Mass by volume percentage. It is very, very important to remember that. My dear students, the medicines, that is tonic, syrup, different medicine today what we are using, its concentration can be expressed by mass by volume percentage. Fourth unit which is used to express concentration, parts per million, that is ppm. It is defined as the number of parts of solute dissolved in 1 million parts of the solution. That is, solution is very, very dilute. What's the part of the solution? The part of the solution is 10 to the power of 6. So, parts per million is equal to number of parts of the solute divided by number of parts of all the components of the solution into 10 to the power of 6. 10 to the power of 6, because solvent or solution you have to express in terms of million. Parts per million are also expressed in mass percentage, volume percentage as well as mass by volume percentage. This unit is suitable only when the solute are present in trace quantity, that is very, very small quantity. When solute is present, it can be expressed by using unit ppm, parts per million, parts per million. This is the fourth unit which is used to express concentration, that is parts per million. That is, next one, mole fraction, mole fraction. So now, mole fraction of the solution cannot be determined. We can calculate mole fraction of each component of the solution. What are the two component solution? Two components of solution is, one is solute, another one is solvent. Therefore, one we can find out the mole fraction of solute as well as mole fraction of solvent. So, mole fraction of component is equal to number of moles of that component divided by total number of moles of all the components present in the solution. For example, let us consider A and B are the two components present in the solution. A and B are the two components present in the solution. The mole fraction is denoted by notation X, capital X. In physical chemistry, if I use capital X symbol, that indicates what? Mole fraction. Mole fraction of the A and B are the component XA and XB. XA and XB. XA and XB. XA is the, so here from the definition, what is mole fraction of that component? Number of moles of that component divided by total number of moles of all the components. What are the two components present in the mixture? A and B. Now I am finding the mole fraction of component A, mole fraction of component B. Therefore, you take number of moles of that component. Number of moles of that component. Therefore, numerator I had taken number of moles of A, numerator I had taken number of moles of B. What are the total number of moles of components? Na plus what? Nb. Na plus Nb. Therefore, mole fraction of component is equal to number of moles of that component divided by total number of all the components present in the mixture. For example, in a binary mixture, Nb moles of solute is present in Na moles of solvent. Nb moles of solute present in Na moles of solvent. Mole fraction of solute Xb. This is mole fraction of solvent is equal to Xa. So here component is B. Therefore you take number of moles of B. What are the two components A and B? Therefore you take Na plus Nb. While calculating XA, the denominator remains same, Na plus Nb. But numerator, you have to take number of moles of A. Therefore, numerator becomes what? Na. Therefore, what's the mole fraction of solute? Mole fraction of solute is equal to Xb is equal to Nb divided by Na plus B, Nb. Mole fraction of solvent Xa is equal to Na divided by Na plus Nb. Okay, for a solution that contains large number of components like A, B, C, D, E, etc. If you want to find out the component of D, you take number of moles of D divided by total number of moles of all the components, that is Na plus Nb plus Nc plus Nd up to Ni. Therefore, if you want to find out mole fraction of any component, number of moles of that component should be taken in the numerator and number of moles of all the components which are present. Okay. So now when you consider A, B and C, three components present in the solution, if you want to find out Xc, if you want to find out, take number of components of C, that is number of components of A, B plus what? C. So this is Xc is equal to Nc divided by Na plus Nb plus Nc, Na plus Nb plus Nc. This is how do you calculate mole fraction. Mole fraction, sum of mole fraction of all the components present in the solution is always equal to 1. That is Xa plus Xb is equal to 1. Xa plus Xb is equal to 1. Xa plus Xb is equal to 1. What is the unit of mole fraction? In the numerator also number of moles, in the denominator also number of moles. Therefore, the unit gets cancelled. Therefore, X does not, mole fraction X does not have unit because the unit gets cancelled, because in the numerator also number of moles, denominator also number of moles. Therefore, what's the unit of mole fraction? Mole fraction does not have any unit. So what's the value? Total of the sum of mole fraction of all the component is always equal to 1, and mole fraction of solution cannot be determined. The mole fraction of each component can be determined. Mole fraction of each component can be determined. That means you can calculate mole fraction of solute separately and mole fraction of solvent separately. Mole fraction of solution cannot be determined. So today in this session, I discussed about, had given definition about solution and what are the two components of solution, my dear student, solute and solvent. Which is the large excess solvent, the smaller proportion is called as what? Solute. There is a binary solution which having two components. Depending upon the physical state of solvent, there are how many types of solutions? 3 types of solution: solid solution, liquid solution and gas solution. Solid solution, liquid solution and gas solution. Further, there are 3 types. Totally today I discussed about 9 types of solution, and solution is expressed by concentration. What is concentration? The amount of solute present in the given quantity of a solvent. The concentration can be expressed by using 8 units. Today I discussed about the first 5 units of concentration like mass percentage, volume percentage, mass by volume percentage, ppm and mole fraction. Today I discussed how many units? 5 units, which are that? So mass percentage, volume percentage, mass by volume percentage, mole fraction as well as what? ppm. In next class, I am going to discuss about the very important units of concentration, that is molarity, molality, normality. After that, I am going to solve some numericals. Okay. So this is next session. Today's session, I have given all basics about what? Solution. Thank you, my students. Goodbye.